Welcome to this tutorial on persistent volume claims in Kubernetes. In this video, we'll explore how pods request storage through PVCs, which is a fundamental concept in the Kubernetes Storage Series. Persistent volume claims provide an abstraction layer that allows applications to request storage resources without worrying about the underlying infrastructure details. A persistent volume claim, or PVC, is a request for storage made by a pod. Just like pods request CPU and memory resources, they use PVCs to request storage. The beauty of PVCs is that they abstract storage details from application developers, allowing them to focus on their applications rather than storage infrastructure. PVCs automatically bind to available persistent volumes in the cluster, and they decouple storage provisioning from storage consumption, making storage management much more flexible and scalable. Let's look at the basic structure of a PVC. It starts with the standard Kubernetes API version and kind fields, specifying this is a persistent volume claim resource. In the metadata section, we give it a name, in this case, myPVC. The spec section is where we define our storage requirements. Here, we specify the access modes, which determine how the volume can be accessed, and the resources section contains the actual storage request. In this example, we're requesting 10 gigabytes of storage. Kubernetes supports 3 access modes for PVCs. First is ReadWriteOnce, abbreviated as RWO, which allows the volume to be mounted as read-write by a single node. This is the most common mode and is suitable for applications running on a single node. Second is ReadOnlyMany, or ROX, which allows the volume to be mounted as read-only by multiple nodes simultaneously. This is useful for sharing data that doesn't need to be modified. Finally, ReadWriteMany, or RWX, allows the volume to be mounted as read-write by multiple nodes at the same time. This mode is typically used for applications that need concurrent read-write access from multiple nodes. The storage request is a critical part of the PVC specification. In the resources.requests.storage field, you specify the minimum amount of storage your application needs. In this example, we're requesting 10 gigabytes. When you create a PVC with a storage request, Kubernetes will search for a persistent volume that has at least this capacity and bind the PVC to it. It's important to note that if a larger volume is available, the PVC will be bound to it, but you'll only be able to use the amount you requested. Now let's see how a pod actually uses a PVC. In the pod specification, we define a volume section where we create a volume named myStorage. Instead of specifying storage details directly, we use the persistent volume claim field and reference our PVC by its name, myPVC. In the containers section, we mount this volume using volume mounts, specifying the volume name and the mount path where the storage should be accessible inside the container. In this example, the storage will be available at /data inside the Nginx container. This abstraction allows the pod to use storage without knowing anything about the underlying persistent volume. The PVC binding process happens in 3 steps. First, a user creates a PVC with specific storage requirements, such as capacity and access modes. Second, Kubernetes automatically searches for a matching persistent volume that satisfies these requirements. The control plane continuously monitors for new PVCs and tries to match them with available PVs. Third, once a suitable PV is found, the PVC binds to it and becomes available for use by pods. This binding is exclusive, meaning once a PVC is bound to a PV, that PV cannot be claimed by any other PVC. A PVC goes through several lifecycle states. The pending state occurs when a PVC is created but hasn't yet been bound to any persistent volume. This usually happens when there's no available PV that matches the PVC's requirements. The bound state means the PVC has been successfully bound to a PV and is ready to be used by pods. The lost state indicates that the associated PV has been deleted or lost, meaning the storage is no longer accessible. Finally, the available state applies when a PV has been reclaimed and is available for new claims. Understanding these states helps in troubleshooting storage issues and managing the lifecycle of your persistent data in Kubernetes.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.